Greetings, this is Rob, Chief Flight Instructor for VATSTAR.com, and after this lesson we'll find out what's at the center of it all. The center of it, thank you. Now to keep the video at a reasonable length, I'm going to go through it kind of quickly, so pause and rewind as you need to, and if you still have questions, my contact information will appear at the very end. Let's start with a few vocabulary words. Tail. That can refer either to the vertical fin sticking up at the back end of an airplane, or it might generically refer to the whole back end of the plane. Aft, well, that's another one of those boating terms that aviation borrows. It means toward the back of the plane. And your payload refers to everything the plane is carrying, including the crew, the passengers, the baggage and other cargo, food, drinks, and other supplies. As pilots, we generally refer to the payload in terms of its weight and weight distribution. So the main topic of this lesson is an aircraft's weight and balance. And those things are related, but they're separate. So first, we'll start with the weight. An aircraft's specifications will usually list a maximum safe operating weight. Obviously, you can't load the plane down with more weight than the amount of lift it generates, right? Well, duh. But when a plane is over its max weight, it still might be physically possible to gather enough lift to get it off the ground. But its controllability, climb performance, stall performance, and other handling characteristics will all be compromised. Some aircraft list just that single figure, but many will list several different categories of maximum weight. You might see a maximum ramp weight, a maximum taxi weight, a maximum takeoff weight, and a maximum landing weight. This is more common in larger planes like commercial airliners, and the idea is the plane is getting lighter as it burns fuel. So you can start at a certain weight on the ramp while you're boarding and getting ready, but by the time you start taxiing, you need to be down to the max taxi weight. Then, by the time you get to the end of the runway to start your takeoff roll, you need to have burned down to the max takeoff weight. And finally, you'll burn a lot of fuel in the air, so when you get to your destination, hopefully you'll be under your max landing weight. Since touching down puts so much stress on the landing gear, it's pretty important to adhere to that landing weight whenever possible, and that's why when planes have in-flight emergencies, sometimes you'll hear of them having to fly in holding patterns or dump some fuel out before they can land safely. Depending on the nature of the emergency, sometimes risking an overweight landing is the best of several bad options. A key thing to keep in mind as a pilot is that it's your responsibility to ensure the plane isn't overloaded, even if you aren't the one doing the loading. Of course, in the sim world, you're in total control. Also in the sim world, there's no one enforcing maximum weights, but your simulator is designed to attempt to replicate how a poorly loaded or overloaded plane will handle. So to ensure the controls react the way they're meant to, pay attention to how you're loading your aircraft. The second part of weight and balance is center of gravity. That's the point at which an object will balance. In aviation circles, it's usually abbreviated CG and represented by this little round symbol. It's not necessarily at the object's center. The weight distribution might be skewed to one side, and in an aircraft, it's very often decided where the engine is located. In fact, a large majority of aircraft are intentionally designed so that their center of gravity is ahead of where the wing's lifting force is. So in theory, if you lifted a plane just by its wingtips, it would tip over forward. As a side note, that means that when the plane is flying forward, in order to keep the nose level, the tail of the plane actually has to generate a downward pushing force. Now you might be thinking, that's got to be terribly inefficient. Why wouldn't you make both generate lift and put the center of gravity somewhere in the middle? Well, for one, you see this concept of opposing forces in vehicle control come up a lot because it's critical for the sake of stability. Think of how your car's front wheels are aligned. They're set so that they point ever so slightly inward, right? It sacrifices a bit of efficiency over pointing them straight ahead, but the result is steering that's much less floaty and more precise. But anyway, where was I? Oh yeah. The main reason you see this design in aircraft is that the plane needs to have a natural tendency to go nose down when lift is reduced. This is critical for safety and stability and the prevention of and recovery from stalls. And if you're thinking to yourself, wow, this is the third straight lesson where he's mentioned that. Well, yeah, it's that important. When it comes to managing the balance of an aircraft, the pilot has two main responsibilities. One is during loading, and as we mentioned, this is the pilot's job to supervise even if he's not the one doing it. The weight might be under the maximum, but if the balance is off, the CG is too far back or what have you, the plane's not going to be controllable. The second is managing the consumption of fuel and which fuel tanks the engines are pulling from at any given moment to make sure that what's left in the tanks is still balanced properly. In the Cessna Skyhawk, you can pull from either the left wing tank or the right wing tank, but most often you leave it pulling from both. In the Mooney Bravo, the selector is either set to left or right. The pilot has to cycle it back and forth every 15 to 30 minutes or so to keep the plane from getting too light on one side. In the 737, there are much more complex options available to the crew for managing the fuel load and rebalancing it if needed. So let's quickly summarize the key points. Weight and balance are critical to aircraft controllability. Weight and balance are related but separate. A plane can be underweight but poorly balanced. A plane might have a single maximum weight or separate maximums for different phases of flight. The pilot is responsible for the proper loading and balancing of the plane. And the pilot must monitor and manage the fuel consumption during the flight to keep the plane balanced throughout. Got it? Good. If you have any questions, shoot them over to me in an email to cfi@vatstar.com. We'll see you in the skies.